So what I want to convey is that if I am given the spectral distribution, things get really simple. Okay, it's just a question of plugging in, understanding that certain terms become fractions, which you can obtain from the tables, and then calculating the total emissivity. If I have the total emissivity, calculating the emissive flux is a piece of cake. So, we've been talking all about emissivity. What about the rest of radiation? What about the portion that's absorbed and so on? We do exactly the same thing. Okay? So for radiant rays incident, radiation incident on a surface, okay, which means that this is radiation coming from all the sources that are surrounding a given surface. I'm sitting in this room, you're all radiating good energy to me. We need to understand how much of it I'm absorbing and going home and reflecting on my pains. Right? So, radiation incident, subscript is little I. Radiation emitted, subscript was E. Exactly the same thing, the intensity of the radiant incident energy is I lambda comma I, lambda comma theta comma phi. This is the intensity of the radiant energy incident on a surface. Intensity of radiant energy incident on a surface. But you see, surfaces are discerning creatures. And we are going to be looking primarily at opaque surfaces. Okay. If I have an opaque surface, if some radiant energy is falling on me, I will absorb a portion of it and I will reflect the rest of it out. The portion that I reflect is not going to increase my temperature. The portion that I absorb is going to increase my temperature or my internal energy. And so, out of the amount of radiant energy incident on me from an external source, I'm going to absorb only a small portion of that. And so, alpha, lambda, theta, lambda comma theta comma phi is the fraction of the radiant incident intensity that is absorbed by a real surface. And this is I lambda comma I absorbed ABS by I lambda comma I. This is the function of all of that, and so this is called a spectral hemispherical absorptivity. And this creature here is the intensity of absorbed radiation. Two more minutes. But once again, this is quite devious because it's a function of lambda, it's a function of theta, it's a function of phi. It's actually a function of the surface roughness, surface characteristics of the absorbing surface, of me, if I'm absorbing energy from you. But it is particularly not a temperature or function of the temperature of the absorbing surface. Please notice there is no temperature put here. Okay? As opposed to putting it for emissivity. And like we did for emissivity, we said this is too much for me. Let me just handle pieces of information, digest it on a piecemeal approach, and then see what the results are. So we define alpha lambda, exactly the same thing. This is defined as a function of lambda, and this is integral 0 to 2 pi, 0 to pi by 2, lambda comma I absorbed sine theta cos theta, d theta, d phi. Watch out and don't do this mistake. When I define absorptivity, the denominator at this point in time has nothing to do with an ideal surface. There is no suffix b here. Okay, so the same thing should be holding there. This is 0 to 2 pi, 0 to pi by 2, I lambda comma I total incident, sin theta, cos theta, d theta, d phi. Or this can be written as spectral irradiation by the spectral irradiation absorbed. Okay, so this is G lambda absorbed by G lambda. So G lambda is spectral irradiation. I'll write it out and then I'll complete it. Spectral irradiation flux. Okay, this is the same as E lambda, its counterpart, but this is an absorption. And the very last thing, alpha, is just integral 0 to infinity, 0 to 2 pi, 0 to pi by 2, lambda I absorbed, sin theta, cos theta, d theta, d phi, d lambda, divided by the net irradiation from the surroundings, 0 to 2 pi, pi by 2, lambda I, sin theta, cos theta, d theta, d phi, d lambda. And this is what we know as G absorbed by the total G. Capital G is irradiation. G absorbed is the absorbed portion of the irradiation. And with this we have done with all the formulas required for radiative heat transfer. We just need to apply them from now on. Okay? Thank you for your patience. Have a good break. Please be safe. And I have office hours today. If you'd like to ask questions on the homework. The homework is not due today, it's due next week, Tuesday. But you should be able to complete it, not this weekend. You should be able to complete it by Sunday this week.